Stratified sampling is one of the type of probability sampling method. So stratified sampling is a probability sampling technique used in statistics and research to divide a population into subgroups or strata based on certain characteristics or attributes and then take a random sample from each stratum. This method is commonly used when researchers want to ensure that the sample represents different subgroups within the population and when there are variations of interest within those subgroups. So there are key steps involved in stratified sampling we need to understand. First, as we know, for sampling population is required. So population identification is must. Define the population of interest that you want to study. This could be a group of people, objects, events, or any other entities relevant to your research. Then we need to do stratification, divide the population into mutually exclusive and collectively exhaustive strata or subgroups based on a specific characteristics or attributes that are relevant to your research objective. The goal is to ensure that each stratum is internally homogeneous and that the strata collectively cover the entire population. Means we can say within a strata it should be homogeneous and between strata it should be heterogeneous. So some another steps we need to understand: sampling frame. Create a separate list or sampling frame for each stratum. This list should be contain all the elements like individuals, items, events belonging to that stratum. Then sample size allocation. Determine the sample size or proportion that you want to allocate to each stratum. This can be based on the relative size of each stratum within the population or other consideration such as the need for more precision in specific subgroups. Then random sampling. Within each stratum, use a random sampling method such as simple random sampling or systematic sampling to select the required number of elements. Ensure that the sampling method used within each stratum is random so that every element within the stratum has an equal chance of being included in the sample. And after that, data collection. Collect data or information from the selected elements within each stratum. This data collection process may involve surveys, interviews, observations, or any other appropriate data gathering techniques. Then analysis. Analyze the data collected from each stratum separately. You can calculate descriptive statistics, perform hypothesis tests, or make inference based on the data within each stratum. And some advantages of stratified sampling: improved representation, ensure that all subgroups or strata within the population are represented in the sample, making the sample more representative of the entire population. And increased precision, provides more precise estimates for each stratum, which can be valuable when there is variation of interest within different subgroups. So advantages like comparisons allows for meaningful comparisons between strata, making it possible to assess differences or pattern across different groups. And one important point, efficiency can be more efficient than simple random sampling when there is significant variability between the subgroups, as it allows for more focused data collection efforts. Flexibility can accommodate complex population structures and research objectives by tailoring the sample size and sampling methods to each stratum characteristics. So we can say stratified sampling is widely used in various fields including social science, marketing research, epidemiology, public health, and quality control to obtain accurate and informative samples from population with diverse characteristics.